Hello, my name is Eleanor Simon, and today I'm gonna be explaining how to calculate a concentration of ions mixed into aqueous solutions. So the example today would be, what is the concentration of chloride ions in a solution formed by mixing 50.0 ml of 0.100 molarity of magnesium chloride with 20.0 ml of 0.150 molarity of iron chloride. So first, let's write what we have. So what we know, our data. So for magnesium chloride, we know that the molarity is 0.100 molarity, and then the volume is 50.0 ml. And then for iron chloride, molarity is 0.150, and the volume is 20.0 ml. So since we're adding two aqueous solutions, the volume is gonna change. So in order for us to calculate our total volume, of course it's adding both volumes up. So it will be 50.0 ml plus 20.0 ml, and that's gonna be 70.0 ml. So now, in order to calculate the chloride ions in from the solution, we first have to calculate, not calculate, but write down our equation in order to know the reaction and to properly calculate the ions. So first, we know this magnesium chloride, they said it's aqueous solution, so it's aqueous, plus iron chloride, that's also aqueous. In order to calculate our product side, we have to separate our ions from magnesium chloride and iron chloride, and do the inside outside rule. So for magnesium chloride, it's gonna be magnesium 2 plus Cl minus, and then for iron chloride, it's gonna be iron 3 plus and then Cl minus, and they have okay, wait, hold on. So I'm gonna do the product side. So it's gonna be magnesium Cl2. So now for this part, in order to calculate the state of magnesium chloride, you have to see your solubility table. So when you go on your solubility table, you go on magnesium chloride, and then magnesium, and then look for chloride. So it says that it's soluble, so that means it's aqueous. But here it's the same thing, and it said that it's aqueous, but okay. So then plus so 3, and then you go again. It's just the way you see this, I'm explaining how to see the state of something, like a compound. You have to go on your solubility table. This is happening because they they keep the same stage since they share an ion, so there's no reaction. This is a no reaction. So that's why it's because they share an ion, so that would be chloride. But it's not always gonna be this way, so you always have to check the stage of your products, because this is something that's not always gonna happen. So yeah. So then we already have our equation. So they're asking us for the concentration of chloride ions. So what we're gonna do is we're gonna calculate the concentration of chloride ions in magnesium chloride, and then iron chloride. So we have to write our stoichiometry map. So as I said before, we first, since we have our molarity and volume, we can calculate the moles of magnesium chloride. So it would be magnesium chloride, then 2 moles of magnesium chloride, and then 2 moles of oh my god, chloride, of course. Okay, so then after this, remember that your volume has to be on liters. So we're gonna take our 50.0 ml and divide it by 1,000. It's gonna be 0.05. Oh my god, sorry. Liters. And then in order to calculate the moles, you have to multiply the volume with the molarity. It's gonna be this. So 0.5 multiplied by 0.100. It's gonna be 0.005 moles of magnesium chloride. So then, in order to turn this to moles of chloride, we're gonna see our equation. So for 1 mole of magnesium chloride, how many moles of chloride is, you gotta see the ratio. So you see for 1 mole of magnesium chloride, there's 2 chloride ions. So oh my god, sorry, that's 2 moles of chloride. So then now you multiply the moles of magnesium chloride by 2, and so that's gonna be 0.01 moles of Cl minus, but I'm gonna turn it to scientific education, but because it's no longer, so it's gonna be 1.8, I believe. Should I put this? Yeah. Okay, so then what we do now is the same thing. We do the same thing for iron chloride. So it would be 3, then the moles of iron Cl3, then moles of chloride. So then it would be, we also change a 20.0 ml to liters, so you divide it by 1,000. It's gonna be 0.02 liters, and then multiply by 0.150 molarity. 0.150. It's gonna give me 0.003 moles of iron chloride. So now we do the ratio, so we can change it, we can convert it to chloride ions. So for 1 mole of iron chloride, it's gonna be 3 moles of Cl. So now this multiplied by 3, it's gonna be 0.009 moles Cl minus. That would be Yeah, so what we do now is that we add both of this, like moles. So it's gonna be oh my god, we have to move this. They have to be in the same oh my god, in the same scientific notation. So oh my god, no, I'm gonna do 1 0 point right, yeah, -3 plus 9.00 e -3, and that's gonna be equal to 19.00 e -3 moles Cl minus. But they're asking for like the concentration, so like molarity. So that's when we're gonna use our total volume and then the moles. So that's gonna give us like the overall like molarity of the whole solution of like chloride ions. Like, oh my god, I don't know if I said that right, but like we're gonna calculate the molarity with the total volume, and now the moles of both magnesium chloride and iron chloride. So molarity, oh my god, this let me write in a different color because I don't want to like erase anything. So now what we're gonna do, we're gonna use this. So then after we like add like the moles of Cl minus from magnesium chloride and then the moles of Cl minus from iron chloride here, as you can see, then we can like finally like calculate the overall concentration of chloride ions, or what they do, in the solution. So remember at the beginning we calculated the total volume, that would be 70.0 ml, but we have to change that to liters, since the equation for molarity is, let me write it in a different color. So molarity, it's equal to moles volume, but volume in liters. So then we're gonna take our calculator, so 70.0 ml divided by 1,000, and that's gonna be 0.07 liters. So it will be 0.07 liters. And then let me change this to 1.900 e -2 moles. Okay, Cl minus. So then we put our moles, 0 e -2 moles Cl minus. So then that's gonna be 1.900. Let me put in the calculator. E -2 divided by 0.07. That's gonna give me 0.271. So then the answer will be 0.271 molarity. Okay, the molarity of Cl minus. So that should be it. Thank you.